In this problem, we're looking at the function of a ball that's been thrown in the air. So t represents the seconds and s represents the height in feet of the ball's position. So the function we're considering is s of t equals 64 minus 16 times the quantity t minus 1 squared. So question part A wants us to construct a graph of this function on a small time interval. So Eric, how would you go about drawing that graph?
There's a couple different ways, but one tried and true method is just to make a table and plug in different t values and see what kind of s or y values you get out. So I'd start with like plugging in 0 and 1 and 2 and 3 and maybe filling in with 1/2 and 1.5 and so on. So when you plug in 0, I think I get 64 for the height.
Yeah, that's the easy one.
I think
That's
1's
good.
pretty easy too, right?
Yeah, 1 would be pretty easy too because, oh, wait a minute. When you plug in 0, that's not what you get. You don't get 64. That's when you plug in 1.
All right, you get 48, right? Because you get 64 minus 16. So
Right, so when you plug
you
in
get
0, you get 64 minus 16, right? So 48.
48. Yep.
Practice our mental
And
math
I think
here.
same thing for when you plug in 2, you get 48 because you get 64 minus 16 again.
Mm-hmm. And then when you plug in 3, we should get 16 times, so 64 minus 16 times 4, and 16 times 4 is 64. Okay, so this could be helpful too to determine what our axes should look like, because if I put on the y-axis the number is 1, 2, 3, 4, I would see that I'd have a hard time graphing that because these s values I'm getting out are so large. So instead, maybe I want to put the numbers 1, 2, 3, 4 on the x-axis, but on the y-axis, maybe I want to put, what do you think? Maybe 10s? Oh, I don't think I put enough. Oh, that'll be okay.
Sure, 10s or 16s. I mean,
we'll just extend this a little bit. So, okay, so at 0, it's at about 48. At 1, it's at 64, so it'll be up a little bit higher. 2, it'll be at 48. And then at 3, it'll all the way be down here at 0. Okay, and we know that this looks like a parabola because it has this square in it, right? Now let's actually see if I can shrink this. Oh, look at that. Okay. I'm getting to know the tools. Okay, so it says in the time interval 0 to 3, but it says to also label at least 6 distinct points, including the 3 points that correspond to when the ball was released, when the ball reaches its highest point, and when the ball lands. So we have when the ball lands here, right? That's at t equals 3 because the ball is now on the ground. And the ball can't really go into negative space. But when do you think the ball was released?
I'm going to go with when t was 0, just because that's when the time started, I guess.
Right. Originally, I was thinking it was when the ball would be at s equals 0 on the first time s equals 0, but that doesn't make any sense, right? Because time would be negative and someone throwing the ball is not laying on the ground. So yeah, so I think this point on the left here would be when the ball is released. And that person, I guess, is standing at 48 feet in the air. So I guess that makes sense. They throw it in the air and then maybe it's coming down.
Yeah.
Okay, so we have these 4
top of one of the buildings on campus.
Yeah, that makes sense. Okay, so we have 4 points. And so if we do a couple more, like you said, we could plug in 0.5. This is going to be challenging for our mental math, but that's okay. So
it's 1/2 squared, so that's 1/4. So 64 minus 16 times 1/4, I think is 60. Did I get that right?
Yeah,
This is
that
where I
looks
just have to
good.
do everything by hand.
And then let's pick like 2.5. So if we did 2.5, that would be 5 halves. Might be easier to do it in our heads.
Mhm.
Over 4, right?
Mhm. Yeah.
And then
64.
that doesn't make sense. Oh, I didn't subtract 1.
I think, yeah. So 5 halves
Before
minus
I didn't
1
subtract 1 before I squared
gives
it.
you 3 halves.
3
Right.
halves
So
squared.
9/4. Yeah. So 9/4. So what's that? 4 times 9, 36.
36. So 28.
Sure.
Okay. And that point really goes to show you that this is very much like a parabola. There we go. Okay, so for the rest of this activity, we want to think about the behavior of the ball on the time interval 0 to 1. So remember at 1, that is where the ball is being thrown upwards. When we get to 1, the fact is this term will become 0. And so it will reach that maximum height of 64 feet, right? Because anything plugged in here, when you square it, will be positive. And so you're always subtracting off something. So the maximum height is going to be at 64 when you're subtracting off 0, and that's at the time t equals 1. Okay, so the behavior of the ball on the time interval between 0 and 1 is that the height of the ball is increasing.
Yeah, the ball's going up.
Right, so the ball is going up. And then on the interval 1 to 3, the ball is coming back down.
So yeah.
Until it hits the ground at 3 seconds. Okay, and the height of the ball is decreasing. Okay, and what about the instant t equals 1? I guess I would say it reaches the highest
it's neither
point.
going up or down. Yeah. It switches from going up to going down. Yeah.
Okay, so now we can consider this expression AB, which represents average velocity, and we can think about it on this time interval from 0.5 to 1. So between t equals 0.5 to 1. So Eric, do you think that the average velocity is going to be positive, negative, 0, just as a guess?
Say positive because we just said it was going up between 0.5 and 1, or between 0 and 1.
Yeah. So so what does it measure geometrically? Well, geometrically, it's going to be looking at the point from 0.5 up to 1, and it will actually be looking at the slope of that secant line.
Mm-hmm.
And so as you can see here, it matches what Eric said. So it should be a positive number. So that's a good check to make sure that we've done things correctly. So if we go ahead and actually solve this, S of 1, we said, was 64, and S of 0.5 is 60. So we get 4 divided by 0.5, which is 8. And what would the units on this be? Well, 64 and 60 are feet. So we get feet in the numerator. And then the 1 minus 0.5, that was measuring time, and in particular time in seconds. So we get 8 feet per second. Okay, so at this On this interval from t equals 0.5 to t equals 1, the ball is traveling upwards at an average rate of 8 feet per second.